Hello, this is video number 14. We are starting chapter 4. So this is chapter 4, section 1. And this is all about simplifying rational expressions. So the first thing, this whole entire chapter is about rational expressions and equations. And the first thing that you need to know is what the definition of rational means. And so a rational number is a number that is defined as a fraction a over b where b is not equal to 0. And if you think about that, that should make sense. That means your denominator can't be 0, which it can't be. It's undefined. If you do that, you get an error in your calculator if you try to divide by 0. And so this whole chapter is about dealing with fractional expressions and equations, which I know you all love so much. Sarcasm. Sorry. Okay, so here is something that you need to know. In varsity or a textbook or anything that deals with rational equations, you're going to be asked for restrictions or constraints. So I will use either of those words as I'm working my way through this chapter. And the restriction or the constraint is what the denominator cannot be. So where the denominator is 0, which we know it can't be, where the denominator is 0 is considered a restriction. So you're going to have to find those. Let me give you an example. If you see something like 3 over x minus 4, you should be able to look at this denominator. This one's real straightforward, which is why I picked this one, and know that if we let x equal 4, then the denominator is going to be 0. Right? So we can actually find that by setting the denominator equal to 0 if it's something that you're unsure of, and solve for x. And so our answer now is x can be anything except that value. And so there's different ways for you to answer this, but you could say x is everything not equal to 4. You could say all real numbers not equal to 4. You could say we go from negative infinity to 4, and we combine that with 4 to infinity, right? Oh, this would be called interval notation. We did that earlier in the year and last year. And what varsity is going to use is this one right here. The x is not equal to 4. So you'll see x is not equal to and a box, and you just fill in what the box is. So these are finding the restraints or constraints or the restrictions on that function. Okay. Now, this is also, that constraint is also called the domain. So the restrictions also create your domain, which you may remember the domain represents all x values in a function. Well, in a relation, we'll put. Okay, so all x values that are going to actually work. So if you're asked for the domain, that means you're being asked for what values of x will work. The restrictions are what you need to make sure that you're allocating for so that the denominator does not equal 0. Okay? So let's look at another one, a little bit more complex function. Well, not function, but expression. If you see x squared minus 1 over 2x minus 2, the numerator is completely irrelevant when you're talking about the restrictions or the constraints or the restrictions, okay? So we want to set the denominator equal to 0. And solve. So we're going to take 2x minus 2 equals 0. Move the 2. It'll become positive. Divide by the other 2. And we have x equals 1. And so you would say x can be anything except 1. Okay, so this is going to be your restriction, which is also your domain. All right, and you're going to be asked for those in the varsity questions. It asks that underneath the answer to the question, but I would actually do this first to make sure that you're solving it correctly, and then go and actually solve the problem. Okay, so let's go through a couple rules of fractions that you may have forgotten because you've relied on your calculator for far too long. And then we'll do a couple of examples that the book will show. So, okay. A couple things with fractions that you should know. Remember that you need a common denominator to add and subtract, but not to multiply and divide. Okay. Factoring comes into play pretty big here. And actually, we get more into the rules of fractions in the next section. So let's just take a look at what these problems are going to look like and then go from there. Okay, so you're going to get a problem that looks like this. 48x to the third minus 3 over 12x squared minus 21x minus 6. And you're going to be asked to simplify. Okay, so what that means is that you need to factor this expression, factor both the numerator and denominator. And then cancel any common factors. All right, so we're going to take this thing, and you should notice that there's a GCF in both the top and the bottom. We can pull a 3 out of there, leaving us a 16x squared minus 1 on top. And then on the bottom, if I take a 3 out, I get 4x squared minus 7x minus 2. Okay, now your job is to identify what type of factoring you have to use. You should recognize the top as a difference of squares. And so this is going to be 4x plus 1 and 4x minus 1. And the bottom, you can X method. So I get a negative 8, negative 7, negative 8, positive 1. Divide by 4, divide by 4. This one reduces to negative 2 over 1. This one I can't reduce. So I get 3 times x minus 2 and 4x plus 1. Now remember, you can cancel a common factor from the top and bottom numerator and denominator, only when the expression has been factored and is now a multiplication problem. Students, a lot of times, because of the heavy reliance on calculators, you guys don't know how to cross cancel. And you don't do it legally. It's a little disturbing. So you can only cancel when you have a multiplication problem. So here's what I mean. I'm going to use a highlighter here, yellow highlighter. The original problem, these are added and subtracted, right? 48x cubed minus 3. That's a subtraction problem. So is 12x squared minus 21x minus 6. That's addition and subtraction, right? So this guy is an addition subtraction problem. However, once we factored it, take a look at what you have over here. These are all multiplied by each other. You have 3 times the quantity 4x plus 1 times the quantity 4x minus 1 over 3 times the quantity x minus 2 times the quantity 4x plus 1. Those are all multiplied by each other. So that can be factored. You can cancel from that one. You cannot cancel from the one in yellow. Okay, so don't be thinking because these two things over here, -3 and -6, looks nice. Can't cancel those. Add and subtract. This guy over here in the blue, you can cancel. So notice that there's a 3 on the top and the bottom. I can cancel those out. And I have a 4x plus 1 on the top and the bottom. I can cancel those out. And so the answer to this problem is what is left over on the top. So the answer to this, on the top you have 4x minus 1, and on the bottom you have x minus 2. Now when you type this into Varsity, make sure that you put parentheses around any binomials, okay? Because if you don't, you're going to end up with something that looks wonky like this. 4x, if you do this, 4x minus 1 divided by x minus 2 is going to look like this. 4x minus 1 over x minus 2. And this does not look like this. So you need to make sure you put parentheses around all polynomials. If it's not one term, when in doubt, put parentheses around it. Okay? So this is the goal. We're going to take these expressions that look sort of complicated. We're going to factor them, and then we're going to turn them into much more concise, reduced answers. Okay? So if you can't factor well, this is going to be a problem for you because there's all sorts of different factoring techniques. I'm going to do two more factoring problems and then one problem that does some substitution. So here is the next one. We're going to simplify xy minus x plus y minus 1 over xy plus x plus y plus 1. And you should be looking at that automatically thinking, oh, there's 4 terms. I know I need to group. I have to do grouping. So remember, when you do grouping, you're making 2 sets of parentheses with a plus sign in the middle. So I'm going to group the first 2 together. And remember, it doesn't have to be the first 2, but they have to have a common factor. And if you need to review factoring, it's back in chapter 1. I think grouping is like 1.3, so you can go back and take a look there. So I'm going to pull the GCF out of each one. Y minus 1. This doesn't have a GCF, so I can pull a 1 out. The big important thing here is that my 2 binomials are the same. Okay, next step is going to look like x plus 1 times y minus 1 over x plus 1 times y plus 1. These are common factors. They would go away. Don't leave your answer like that either. Just cancel those out and be lazy and leave your answer looking like that. Don't do that. Rewrite it. Make sure that you're showing all the steps and then box your answer. Okay. All right. So that's how we do that. And then, yep. Okay. And then the next one that I want to do just talks about factoring a negative out. So this one starts like this: y minus 8 over 8 minus y. Well, your variables should always come first. So switch the order of these and be very careful with your signs. The 8 is positive, the y is negative, right? So when I turn this around, the y is negative and the 8 is positive. And then you shouldn't ever leave a negative on a leading term. So make sure you factor out this negative. So this is now going to look like y minus 8 over negative 1 times the binomial y minus 8. And then you can cancel the binomials y minus 8, and you're left with 1 over negative 1, which is negative 1. Okay, so it's possible that all of your actual variables could cancel out, and you're going to be left with just a number. Also, I haven't really talked about the restrictions in these. And this one, let's just look at this one real quick. So back here, you would take this part, the 8 minus y, set it equal to 0, move the y, you get 8 equals y. So the constraint is actually y cannot be 8, right, if you're asked for a restriction on that. Excuse me. All right, and then the last example that I want to take a look at is substitution, but then it also has to do kind of with what you're doing. So it says for the function f of x equals negative 5x plus 9, find, and there's an a and a b. A, f of x minus f of a all over x minus a. And then b, f of x plus h minus f of x all over h. All right, so this goes back to your substitution. Remember that if you have something like f of 2, so recall f of 2 means replace, substitute, whichever word you want, all x's with a 2, right? So here, this first part of this just says replace all x's with an x. Well, that would be exactly the function. Excuse me. So I have negative 5x plus 9. And then I have minus f of a. So minus, put your f of a in parentheses and replace all x's with a's. Minus 5a plus 9. Make sure you put the parentheses around there, or you're going to have a problem. And the bottom, there's no f's, so I'm just putting x minus a in there. Now we're going to go through and simplify. So I have negative 5x plus 9 plus 5a minus 9 all over x minus a. Well, if we take a look at that, we can cancel out the 9's. That leaves us a negative 5x plus 5a over x minus a. The leading term on top is negative and shouldn't be, so I'm going to factor out a negative 5, which leaves me x minus a over x minus a. And now I can cancel those x minus a's, leaving me just negative 5. Okay, so the algebra here is not difficult. What's difficult in these problems is you understanding the substitution at the very beginning and getting this part correct. And part A here is easier than part B, because in part B, we're substituting a binomial essentially in for x. So what's this guy going to look like? I'll rewrite the function right up here since it disappeared. F of x equals negative 5x plus 9. So this is the function that we're using for the substitution here in part B. All right, so I'm going to take and put an x plus h anywhere there's an x. So I have negative 5 times x plus h plus 9. That would be the whole function, all right? Now I'm going to subtract off f of x. Subtract off negative 5x plus 9, and it's all over h. All right, well, we've got a bunch of simplifying we've got to do here. Let me get some more space. So I'm going to distribute on top and simplify. So I have negative 5x minus 5h plus 9 plus 5x minus 9 all over h. All right, well, these are designed so that generally you're left with terms with h in them. So you'll notice the x terms have different signs, so they cancel each other out. The constants have opposite signs, so they cancel out. So we're left with negative 5h over h, and then the h's cancel out, and we're left with negative 5. And it just so happens that these two have exactly the same answers when we go through and do that. So I don't know if that will happen in all of the problems, but in this one it did. All right, so that's simplifying these things. And then our next section is going to be multiplying and dividing. Toodaloo for now.